Well, our discussion here of the surface area of a prism, we're going to first start by building a prism, a 3D model. And I'm going to look at the base here, and this young lady is standing on a regular pentagon. Hence, this is, when I extrude this, it's going to be a regular prism. I'm also going to take this pentagon and I'm going to lift it vertically. That is, I'm going to pull it like this and pull it straight up. In this case, 5 meters. And then this is going to be called a regular right prism. And more specifically, it's a regular right pentagonal prism, because after all, it's got a pentagon for each of the bases, and I can see here that I've got 5 rectangles going all the way around like this. And there's just one last thing we have to consider. A lot of people say, well, if it's not, aren't they all right? And the answer is no, because what you have to be aware of is that we could have a prism like this. I could take this prism and I could push it over to the side like this. And then it becomes an oblique prism. And if we look at those sides, I'm not looking at rectangles anymore, but parallelograms. So we are going to be finding the area, that would be the total surface area of this figure, as a regular right pentagonal prism. That's the example we're going to work with. Now let's explode this figure and look at a net. Well, now that we've seen our right regular prism, and this is a pentagonal prism in 3D, let's see if we can flatten it out into a net and then find its surface area. Makes a lot of sense this way. We've got 2 different formulae listed here, but let's just look at intuitively. Well, it makes sense. I've got the 2 bases over here. The first formula, notice 2b, that's the 2 bases. Perimeter h, well, you know, I could just say 4 times 5 is 20, 40, 60, 80, 100. You can do that. You can just add them up separately, but we'll try to make sense of these 2 formulae. Another mention there in the book, there was no mention of these being regular, but clearly these are regular right prisms, since this only is going to work if we have regular polygons as the bases. So let's first make sense of this blue equation. And recalling from last chapter, regular polygon is the area of this regular polygon right here, 1/2 AP, apothem times perimeter. But since there are 2 of them, there's this one and this one, well, if I add those together, clearly it can be simplified just to AP. So that's why the blue formula is written this way. It's just simplifying for you. The AP adds up the 2 bases, and the PH adds up all the sides. So, well, let's get to it. And there's more than one way to show a net, and this is probably not the best one. I like it for being intuitive, but for making this equation work, I think this one works a little bit better. In this case, I've got the 5 sides, the 5 rectangles laid out this way, so that I can see, representing right there, the perimeter can be represented as the single member of this rectangle, so I can see that P times 5 would be the area of all 5 of those rectangles together. And this second base in this net, it could be represented at any different point. It doesn't really matter, because this would still all fold up into the prism. But we'll just leave it there for now. And let's work off the second net and try to make sense of this formula. Okay. Well, let's get rid of that one. And I'm going to expand this triangle. This triangle, because of course I need the apothem. And we recall this from last chapter. We like to use A for apothem, which is pretty convenient. We know this is a 36-degree angle in here, because it's half the central angle of 72 for a regular pentagon. Review last chapter if you're having a problem. B is a given here. Because I know the side is 4, we are using B as half of 4, which in this case is 2. So I've got 2 here. The R is unknown, but you know what? I really don't care, because we don't really need it. So right where all we need to solve for that A. And we think of our trig functions. I've got the 36. Opposite is the b, which is 2, over adjacent. A adjacent, A apothem. Pretty handy. So that tells me it's going to be our friend little Tommy tangent. So the tangent of 36 is b, 2 over A. We rearranged that equation, representing it A is equal to 2 over the tangent of 36. Now we can just substitute into this formula. And again, I prefer to do that and pull out the calculator at the end. So there's the substitution. I've got an expression here, a tangent function for apothem times the perimeter, which is 20, plus 20 times 5. I can simplify that. And then in one shot, we can pull out the calculator, and let's see where that calculator is. Oops, I already got something there. Well, we'll go straight forward here. 40 divided by 36 tangent. Now that's, remember that 0.72 is the tangent of 36 equals, and there's our 55. And we know very well that we just add 100. We don't need a calculator for that. So it's going to be 155, and to the nearest tenth, 1/10. Now, you notice I've left them off. Put your units on, because you know we're working with area. So all of these are going to be square units, and you were given meters, 155 and 1/10 square meters. That's how it's done.